Hi, my name is Joseph Yahuda Yasharao. I am here to expound on the system we're trying to solve. It's a system that's already in existence. They use hydraulic braking these days, and most of them come with drums, and some of them got discs. Obviously, the discs they were brought up into phase out the drums because of trying to reduce the heat they make. Now, with that, this system works very well. There's no doubt about, because it does still save lives and it is still functional. But there is such a great room for improvement. So when you look at the system we're trying to put in, the intelligent braking system, the artificial intelligent braking system, it's just going to replace that with it's automation of itself using data like fuzzy logics that's actually used in AI, and also machine deep learning, techniques like that. Now, if we're to replace that, what are the existing things? Brakes doing today? Some of the brakes existing today, they bind on one side, and if you leave the vehicle for too long, it binds the hose, and it's very difficult to make it release. And sometimes the spring they jam and things like that, and sometimes they pull to one side. This is the type of system we're trying to get rid of all that, because with this intelligent braking system, the AI braking system, is not going to be having any problem with binding, or you can leave it for 30 years and just jump in and drive after that, because there's no issues with binding or anything else with that particular vehicle. So with that particular system, it's got nothing to do with it being standing for a long time with the handbrake pulls and then it jams in that position. It's got nothing like that. These just work electronically, they monitor themselves, and they're very intelligent in that manner. So that's the system we'll be trying to solve and replace, the replacing of the friction brake.
This part of the slide I will be explaining more about what actually happens within the intelligent braking system, the AI braking system. So I'll take you for an example. The Tesla car has got obviously the 4 wheels, but now also those 4 wheels don't have a position where it doesn't know their position. So what actually happens the Tesla car, for example, when the accelerator is off, for instance, somebody remove the foot from the accelerator, it automatically goes into regenerative and then applies brakes, but it doesn't know its position and does not have any where it's going to do some calculations within the wheels themselves. So using this artificial intelligence. So now where does this come from? Basically this I took it from my undergraduate project which I was working on, which came from the train system. I was basically trying to resolve another problem, which was getting rid of the hard starting on induction motors, so which is known as the start delta. So I used the synchronous system that was used to drive the tractions on trains. Excuse me. And here, for example, you have the driver control, which throws signals into that what they call the GDU, the gate drive unit, and also the drive control units. Now the drive control units throw variables which come from the coach and the speed probe, which are on the wheels of the train, and pushes back into the GDU. The GDU then throws information to be able to know how to fire the IGBTs. The IGBTs will be also converting what they call the direct current DC link here into AC, and then that AC is then used to drive the squirrel cage motor, which is also known as synchronous motor or induction motor. So that's how that system works. Now, how is the system related? Before all this, I had a system that was already running. Again, I was solving this drive unit that I have here. The IGBTs is the same system I had, but now we're showing it with the motor connected. So it drives basically a control unit of the electric motor, and in the electric motor is driven by the IGBTs with the interface system. This system was there before Eurotherm, companies like that, ABB, and Tesla themselves have used this system to run into their system, but now they are a competitor as to, they are part of their competitors themselves at this point. So what I'm going to expound on that is, as a system, it explains itself here. The control, brake control and speed probe is sent from the motor back into the IGBT system. The IGBT then does a calculation to see how much it needs to feed into the motor depending on the weight being added onto the shaft. So this same system is now, that's what I've actually done, is I added the artificial intelligence into it, and so that it does more. So when you're looking at this, it's still the same system, but with the intelligence added into it. And when the intelligence added into it, we are now getting this part here. So we're having two of those induction motors being controlled by something. That system is known as the same system is known as the PCSIM, programmable controller for induction motor. So what is happening within the system is that when we look back into the system here, we are looking at a motor here, but in here the system has got two motors. So what that controller is doing is driving these two motors. Each will be driving a different motor. And now what actually happens as the wheel rotates on the road, it's obviously going in motion. The other one reverses to stop the going into that same motion. The secret is being able to calculate and know how much is being the force that's been given by this wheel when it makes contacts with the tire, with the road. So, and then that way they to calculate how much power to add to the wheel. So depending how much power is to be added to the motor to stop this wheel from spinning. And most importantly, it's more expounded into this system. This is the PCSIM, which was, like I said before, this is like a Eurotherm driver, the people that, took these sort of technologies and used it. As I said, this system was there long before they had their system working. So this is explaining one motor is in brake, one motor is in drive. So that's basically how this system functions to make the car actually come to a halt. Now here we have the same system with the four wheels on there, and it's got the PCSMI system in each wheel. So what basically happens is it's almost solving another problem of the self-driving, self-charging system. Basically would have, charging banks over here, the battery tray, but the battery tray is only for backup if, for instance, the self-charging system fails, so that you still have that, and if all fails you can still plug it in and charge it. So it's still got all those options, but the most important thing it uses that as part of just redundancy, really. So with that, that's the smart part of the system that I'm implementing.
Alright, might as well put on some music. All these weird gadgets, you'd think they'd give you a radio.
What would you like to hear?
What the hell was that?
Do you wish further information on Silicon Valley?
Hell no, I want to know who you are and how you're listening in.
There's no reason for increased volume. I am scanning your interrogatives quite satisfactorily. I am the voice of Night Industry 2000's microprocessor. KITT for easy reference. A kit if you prefer.
As you can see from the previous clip, that the artificial intelligence involved is actually making decisions on its own. And what type of artificial intelligence are there? There is artificial narrow intelligence, which is ANI, and artificial general intelligence, and strong artificial intelligence. So the strong artificial intelligence is super artificial intelligence. The general artificial intelligence hasn't even been in existence at this point. So where we are right now, we're sitting at artificial narrow intelligence, which is ANI, that type of information where it works on reactions. For instance, like the system uses sensors to react on that. This type of sensors that will be mostly in also a type of data called limited memory AI. This is a memory that's made on decisions of data collection. So where would the data be coming from? From all the sensors that are available. Also, there is something also known as fuzzy logic, which is also in automation of the gears inside. This type of also intelligence used in hospitals for machinery, for medical machines, and other Boolean Boolean algorithms that they can use in also hospitals. Now, looking at our aim at the end of all the sort of research and models and different type of these intelligent braking systems, the AI intelligent braking system, that's machine learning, which will be also based on deep learning. Now, most of the self-driving algorithms are coming off, most what is also known as deep learning, type of data. So, when we're looking at developing this system to make it, more resilient, if I should say, we are looking at the type of data it's going to be collecting from the sensors. These sensors got to be allocated in such a way that they do not fail and make different make the car collect the data and utilize it in the response where it's supposed to be for the safety of passengers on the actual self-driving cars, and the system itself, how it monitors itself around and how it reacts. So with that, with the type of magnetism that is made up in induction motor, the way it will be calculated in the type of what could I say, the chips that will be used, the CPUs or the microcontrollers that will be used to develop this type of system, could be looked at very intelligent to be able to tell each wheel what it's actually doing, and being able to calculate and respond with the distance measured by the sensors, and also area, all these different aspects that the AI will be picking up is the type of data that it will collect, which is looking around about the machine learning of that of limited memory, where it collects information from what its surrounding is depending on the sensors. So with that, it's another area to look at.
According to Bonnie, my new Super Pursuit mode and EBS produce an altered configuration.
According to Bonnie, Super Pursuit mode also gives us 40% more speed. But what's this EBS?
Emergency braking system. I'm quite anxious to see how I look.
Unless I missed my guess, you'll get a chance real soon.
I have it, Michael. May I suggest you try my new Super Pursuit mode?
Why not? If we ever needed an edge, it's right now.
Well, what do you think?
Wow!
I take it you're pleased.
Please, are you kidding? I'm knocked out. You got some serious speed here, pal. Why don't we try our emergency braking system?
Good thinking, Michael.
Woo!
Business plans and revenue are basically after developing the prototype. The prototype is made up of approaching, manufacturers that manufacture components. Some places where they do plastic injection, where they create all different type of machining, is basically starting to get them to machine the parts. Once the parts are machined, then we make a prototype out of the parts, and after the parts, the prototype obviously has to be improved, and then maybe put into we launch it into the market. Now, which market to hit first? Originally, because there are systems that are already existing that are on original cars, it's basically looking at certain models of cars, how the drum discs, how they fit onto there, then machine, the different type of these two types of PCSMI mounted in the same place where they mount the drum disc and the calipers and the disc brakes. All these, where they are mounted, they must be in the same shape, and they use the same sort of shafts, lines, everything else in that context. On that design, they will fit certain cars, and certain cars have to be looked at, measured, and then developed in that matter. So in that area where we are looking at the market, would possibly aim for that, but at the same time we'll develop also the other type that come in for the electric vehicles, which come in with all these the induction motors made up in them, all four of them in each wheel. So what happens is you can also put these into combustion engine type of cars, the gearbox and the differential with them. So basically, when you get all these components made up, it's a wise idea to put them together into certain type of cars after the prototype, and then when the market starts growing, because they are actually showing that they're working and they're proving themselves, this is how the market can actually start growing, and also slowly phase out the friction brakes. This is how the market will grow, and in that sense, we are looking to say the friction brakes will eventually wear out. Although the friction brakes are very reliable and very useful, but if they can still be put into existing vehicles that are on the market today, I don't see why they cannot be phased out as well, because this was obviously stronger and better, as I had explained before in the solution problem earlier. So with that, I will then be looking forward to seeing how the project go again.
With that, I have some other type of vehicle like this one that flies, and also some also that go on water and marines. There are many other different type of vehicles, some that are go on land, some all different types of type of cars and that are used on the market today. Now on my system, we'll be able to go on any type of that type of vehicle similar to this that is flying. What I believe is that complexity is not always the answer, but some will tend to believe so. Many other type of systems that come through the market today are going through the similar sort of systems and structures. It's just the same things like what we got on this system now is something that not any other vehicle would have, that is actually also that of the self-charging system, as well as more power that you're going to get from the DIMMs, the drive, so dual induction motor drive shaft, some stuff like that. DIMMs is something that has not been actually introduced and is out in the world today. It's a type of system that is also coming from the PC. Yes, I am, which also would drive together with AI and will replace this set of system that are existing today. Or most of it, I can say, is just like competitors. I can say that includes Ford, Tesla themselves, Toyota, and all them other manufacturers that are out there, Nissan, all them type of manufacturers. These are all going to become competitors to my system that we are making here. And with that, the design goes through with many types of systems that have never been seen and are resilient. So with that, I'll leave you to watch all these clips of all the other competitors who are there, and then I will come back in the end with explaining and closing down the super intelligence clip that we have forthcoming after you've watched through all these developments of the electric cars that are coming in the future of 2020 and years after.
More and more manufacturers are focusing on developing new electric powertrains and platforms, which could result in the number of electric cars to grow rapidly over the next several years. The fall in prices, improvements in range, increased investment and rollout of charging networks has started to create a serious competition on the market. Big automakers like Volkswagen and Daimler are accelerating the transition towards electric drive, paving the way for the breakthrough of electric vehicles. Today, we'll talk about the top 10 all-electric cars that will hit the roads as early as 2020. Audi e-tron Sportback. Audi, that aims at electrifying 1/3 of all new models, is going to bring its next all-electric car to market in 2020. The newly unveiled e-tron Sportback comes with futuristic design and embedded innovative AI technologies to ensure a comfortable and connected environment for its passengers. The vehicle will be built using the same electric drivetrain and battery as the company's first all-electric car, the e-tron Quattro SUV. But it's equipped with a coupe roof, which makes the vehicle more aerodynamic, allowing it to overcome around 6 miles more distance. The all-wheel drive SUV coupe will be available in 2 options. The higher-end version is expected to have a real-world range of about 210 miles on a full charge. It will be equipped with dual-electric motors for a total regular output of 265 kilowatts and 414 pound-feet of torque. The new electric coupe crossover features an innovative lighting technology with digitally controlled matrix LED units at the front and rear, which can produce excellent light combinations, enabling the vehicle to communicate visually with the surroundings. The Audi e-tron Sportback will have a starting price of about $78,000. Tesla Model Y. Tesla has officially launched its highly anticipated compact crossover SUV, which is expected to come to market in fall 2020. The Model Y's design is remarkably similar to the Model 3's design, but thanks to its 10% bigger size, it can be outfitted with a 3rd row of seats for a total seating capacity of 7. The company offers both rear and all-wheel drive variants, which come with impressive aerodynamic performance, enabling the higher-end version to reach 60 miles per hour in 3.5 seconds. The car is mostly free of buttons on the inside, featuring a large infotainment display in the middle of the dashboard. The vehicle is able to achieve a real-world range of up to 300 miles on a single charge and has a starting price of $48,000. The cheaper version with a smaller battery is due to go on sale in spring 2021 with a price of $39,000. Tesla also has plans to produce a more powerful version of the Model S in 2020, which will come with a 3-motor, Plaid powertrain and new rear-facing seats. The specifications is still unknown, but it will be quicker than the Tesla Model S P100D with ludicrous mode, ready to set new records from an electric sedan. Ford Mustang Mach-E. Ford finally unveils its gorgeous, powerful, long-range, all-electric SUV, which is inspired by the company's iconic muscle car, the Mustang. The Mustang Mach-E comes with the 3-bar taillights and a familiarly shaped grille cutout. The vehicle will be available in 5 variants with both all-wheel drive and rear-wheel drive powertrains, featuring standard and extended range battery options respectively. The company will first deliver the premium and first edition models in late 2020, which can achieve a real-world range of 270 miles with a pair of electric motors powered by an extended range battery, and the premium model with a single motor-driven powertrain can overcome a distance of 300 miles. The rear-wheel drive base model can achieve a range of 230 miles on a full charge and reach 60 miles per hour in about 6.5 seconds. Driven by 2 electric motors, a special GT Performance Edition, which will be available from spring 2021, is able to accelerate from 0 to 60 miles per hour in 3.5 seconds, like the all-wheel drive Model Y Performance variant. The Mach-E offers a spacious interior featuring a large touchscreen in the center of the dashboard for navigation and entertainment, as well as an additional screen in front of the driver for speed and battery information. The Mustang Mach-E has a starting price of $43,900. Rivian R1T. US-based automotive startup Rivian has launched its first all-electric pickup truck, which comes with an impressive all-electric powertrain and special features. It's an intelligent adventure machine with robust and rugged design featuring, as the company describes, a lockable gear tunnel that extends through the entire width of the vehicle and provides more than 350 liters storage area. The 5-passenger vehicle comes with 3 powertrain options, equipped with 4 independent electric motors on each wheel, and the higher-end version provides a maximum 562 kilowatts power capacity and 3,500 Newton-meter of grounded torque per wheel. The ability to control the torque at the wheel and configure the total power output to different levels enables the owners to steer the pickup truck like a tank, which is capable of reaching 60 miles per hour in an incredible 3 seconds. The different power levels match different choices of battery packs, which can provide a range of 230 to 400 miles on a full charge. Inside, it features a 15.6-inch touchscreen display dominating the middle of the dashboard for navigation and entertainment. The company has been working on possible configurations of the R1T to offer owners different options, which could result in a zero-emission camper version of the vehicle. The R1T starts at $69,000, and first deliveries are set to begin in late 2020. We're going to make a comparison video of the Rivian R1T with Tesla's newly unveiled Cybertruck. So don't forget to subscribe to the channel and click the bell icon so you never miss a video. BMW iX3. BMW, that aims at electrifying 25 models by 2023, is going to bring its next all-electric car to market in 2020, which will feature the 5th generation of BMW eDrive technology for the first time. This means that the BMW iX3, which was unveiled at the 2018 Beijing Motor Show, will feature more integrated, powerful and compact drivetrain and battery packs with higher energy capacity. The company classifies the iX3 as a sports activity vehicle that comes with a 70 kilowatt-hours battery pack with an expected peak output of 250 kilowatts and a 150 kilowatts charging capacity. The BMW iX3, which is due to go on sale next year, will be the first model produced for the entire global market at the Chinese production location in Shenyang. Polestar 2. Volvo's performance brand Polestar has launched its first all-electric car, which is due to come to market in 2020. The Polestar 2 is built on Volvo's all-electric, adaptable, compact, modular architecture platform and comes with performance-oriented design, delivering a lower drag coefficient for an enhanced aerodynamic performance. It's the first vehicle that features an Android-powered infotainment system, creating a unique and responsive customer experience. The system provides all the necessary information on the vertically mounted 11-inch display and offers a broad range of services and functions using an in-car version of Google Assistant. A pair of electric motors, one on each axle, that join forces to provide a total output of 300 kilowatts and 488 pound-feet of torque, send the vehicle from 0 to 60 miles per hour in less than 5 seconds. The battery has a total capacity of 78 kilowatt-hours for a real-world range of about 275 miles on a full charge. The all-electric Polestar 2, which has a starting price of around $45,000, goes into production in China to be distributed globally from June 2020. Porsche Taycan. German high-performance premium automobile manufacturer Porsche has finally unveiled the production version of its highly anticipated first all-electric car, which comes with quite stunning design and impressive performance. The Taycan's stylish design, which is very similar to the original Mission E concept, enables superior driving dynamics with an impressive 0.22 drag coefficient. The company is going to bring both the higher-end and base versions of the Taycan to market next year. They're equipped with 2 permanent magnet synchronous motors, one on each axle, which can deliver a maximum power output of 560 kilowatts and 777 pound-feet of torque, enabling the higher-end version of the vehicle to hit 62 miles per hour in just 2.8 seconds and develop a top speed of 162 miles per hour. A newly developed automatically switching 2-speed transmission on the rear axle provides quick acceleration and improves efficiency at high speeds. The 93.4 kilowatt-hours high-class lithium-ion battery pack, which Porsche calls the Performance Battery Plus, is based on an 800-volt technology instead of the usual 400 volts for improved charging and drive performance. As a result, the Taycan will be the first production road car capable of charging at a maximum rate of 270 kilowatts that can deliver an 80% charge in just 22.5 minutes. The cheapest version comes with a 79.2 kilowatt-hours battery pack with a total output of 390 kilowatts and 225 kilowatts charging capacity. Taycan models can achieve a real-world range of 225 to 255 miles on a full charge. The sports sedan comes with a luxury forward-thinking interior offering innovative digital assistant services through several touchscreen displays, and the interactive voice assistant to access all relevant information and control a host of features inside and outside of the car. The Porsche Taycan will be delivered to Europe and the US in the first half of 2020 and has a starting price of around $104,000. Volkswagen ID.3. Volkswagen has finally launched its first next-generation all-electric car, the ID.3, which is based on the company's new MEB platform. The German giant is taking huge steps in electrifying the car industry. The automaker is investing intensively in an all-electric platform and has plans to convert some of their entire gasoline-powered car production capacity to electric vehicle production capacity. For example, the Zwickau factory, where the ID.3 is being produced now, is set to be fully converted by 2022, enabling it to produce 330,000 electric cars per year. The company offers 3 options of the ID.3 electric hatchback with different battery packs respectively, offering an impressive range of 205 to 340 miles on a full charge. The automaker will first deliver the mid-range variant or the first edition, but the price is only known for the basic version, which costs around $33,000. Thanks to the absence of the internal combustion engine, the ID.3 is much roomier on the inside compared to the company's popular Golf hatchback and comes with intuitive user experience and a bunch of high-tech features. The vehicle is controlled by the 10-inch touchscreen display and touch-sensitive buttons throughout the cabin. The ID.3 comes with Volkswagen's latest driver assist features and communicates visually with its occupants thanks to the completely new intelligent ID Light concept. The car will start being delivered to Europe in the middle of 2020. Mini Cooper SE. BMW has launched its second all-electric car, the Mini Cooper SE electric hatchback, which is slated to arrive in the first quarter of 2020. The vehicle shares the iconic Mini design and characteristics, but comes with a completely different powertrain based on the BMW i3 electric powertrain. With a front-mounted electric motor that delivers a maximum 135 kilowatt power output and 200 pound-feet of torque, the car can reach 62 miles per hour in 7.3 seconds, transferring the thrill of its agility and performance. The electric Mini Cooper SE offers 3 style options that come with their own innovative technology and features. With the battery's energy content of 32.6 kilowatt-hours, the vehicle can achieve a real-world range of about 140 miles on a single charge. The electric Mini will be delivered to Europe and the US at the beginning of 2020, and in the US it will have a starting price of $29,900. Peugeot E208. French automobile manufacturer Peugeot has launched its first all-electric production car, the E208. The sharp and smart-looking 5-door electric hatchback offers a smooth and instinctive driving experience. The vehicle comes with the same interior and cargo space as its gasoline-powered counterparts. Inside, it features a 10-inch HD color touchscreen for the center display and a 3D instrument panel display for speed and battery information. The front-mounted 100 kilowatt electric motor is powered by a 50 kilowatt-hours battery pack for a range of 211 miles on a full charge. The electric hatchback will arrive in early 2020 and is now available to pre-order from Europe with a starting price of about $34,000. The French automaker also has plans to bring its production cars to the US and Canada by 2023. Mercedes-Benz unveiled its next-generation all-electric car under the EQ brand at the 2017 Frankfurt Auto Show. The company intends to have more than 10 all-electric vehicles on the market by 2022. The compact electric hatchback has aesthetic appeal thanks to the light technology featuring laser fibers. The black panel at the front end acts as a virtual radiator grille and changes its look and color depending on drive modes. The vehicle will be equipped with 2 electric motors, one on each axle for a total output of 200 kilowatts and 370 pound-feet of torque to send the EQA from 0 to 60 miles per hour in 5 seconds. With a 60 kilowatt-hours highly efficient lithium-ion battery pack, it can achieve a real-world range of more than 200 miles on a single charge. The price and precise delivery date is not clear, but the EQA is expected to arrive in 2020.
As you can see from the previous clip that there is a lot of cars that are going to be competing with my system that we're developing. But in my views, I believe that complexity is not always the answer. But you know how a system works, its benefits, and what it applies and what it can actually do. This is what tells what a system is. With that, I'll let you also look at this car, that Super Night Rider, the Super Intelligence. This is something that we're going to go over, and my system is going to be better than this as well.
Like I said earlier, that these will be my competitors, and my passion is to develop the next clip, which is showing the Super Night Rider car that has, such a lot of intelligence into it. This is using what they call strong AI, and strong AI is a super artificial intelligence. It's my passion. So who am I? About me, I came from a very poor family, and I've done very well with now I have knowledge of extensive engineering knowledge. And where am I with this project? I am just developing the simulation system for the project, and I intend to use, I was using Unity, and I also intend to try to put together a hardware before the sprint goal is complete. The milestone is, as I have passion for developing artificial intelligence and also making this braking system. I want the roads to be more safe and also have this resilient system on the market. With that, I then say thank you for watching. Keep well. Many thanks.